Okay, let's dive right into this explainer and see if we can demystify the somewhat intimidating world of math. Look, a lot of us see complex equations and immediately feel this wave of dread, right? It's like we're staring at some uncrackable alien code. But what if we completely flipped our perspective on that? What if, instead of a source of frustration, we viewed mathematics simply as a series of languages that we can actually learn to translate? Well, today, we're decoding the universe by exploring these mathematical disciplines and the absolute incredible symbols that bring them to life.
Galileo actually hit the nail on the head when he said that mathematics is the language in which the universe is written. It perfectly illustrates our core concept here. These equations, they aren't just random, chaotic marks scrawled on a chalkboard. They're literal sentences. They're written in the alphabet of the cosmos, designed to describe everything, and I mean everything, from the arc of a baseball you just threw to the exact orbit of the planets in our solar system. When you look at it that way, math stops being a chore and actually becomes a really fascinating translation exercise. So, to map out this universe today, we're going to break it down into distinct disciplines: the universal language, arithmetic and algebra, geometry and trigonometry, calculus and higher math, and finally, why these symbols matter.
Let's jump into section 1, the universal language, translating the unknown. Before we start decoding, we need to establish what a mathematical discipline actually is. Basically, it's a specific branch, or kind of like a dialect of mathematics, that focuses on solving particular types of problems using specialized rules and symbols. Just like human languages have specialized jargon, for medicine or law, math has specific dialects for counting, mapping space, and tracking continuous change. I mean, you wouldn't use legal jargon to order a coffee, right? Similarly, you don't use calculus to tally up a simple grocery bill. It's all about matching the right dialect to the exact problem in front of you. Moving right along to section 2, arithmetic and algebra, the foundations. So let's look at the foundational dialects most of us grew up with. First up, arithmetic. This is the study of concrete numbers and your basic operations. You have 2 apples, you add 3 more, you have 5. Super straightforward. But then we introduce algebra. This is the study of mathematical symbols and the rules for manipulating them. While arithmetic deals with hard, concrete numbers, algebra introduces this totally revolutionary concept of using symbols to represent the unknown. It's really the crucial bridge from specific, everyday counting to universal problem solving. It is absolutely wild how simple letters like X, Y, or Z suddenly transform a basic calculation into a total mystery puzzle where we have to hunt down the unknown value. We use the basic operations, plus, minus, multiply, divide, literally every single day. And the equal sign? That represents perfect, undeniable balance. But the second you drop an X into that balance, you're essentially saying, hey, there's a value here, we don't know what it is just yet, but we know exactly how it interacts with everything else. It gives us the power to solve problems backwards, a real game changer.
All right, section 3, geometry and trigonometry, the spatial world.
Notice how the objective really shifts gear here. While algebra focuses purely on solving for unknown abstract values, geometry is all about solving for physical space, shapes, and angles. We aren't just hunting for a hidden number in some theoretical equation anymore. Instead, we're mapping out the literal dimensions of reality. We're using this dialect to calculate the exact square footage of a room, or figuring out the structural integrity of a massive suspension bridge. And enter the Greek alphabet. This is where it famously makes its appearance, giving us a highly specialized visual vocabulary. Instead of writing out a whole paragraph, we have this universal shorthand for an angle, a crisp visual cue for a triangle, and of course the iconic pi symbol, which represents that mind-bending, infinite ratio of a circle's circumference to its diameter. Oh, and then there's theta, which acts as this really elegant placeholder for an unknown angle. These symbols give us a perfectly clear blueprint of the physical world. Which brings us to section 4, calculus and higher math. The mathematics of change. Listen, calculus definitely gets a bad rap, but at its core, it is simply the mathematical study of continuous change, in the exact same way that geometry is the study of shape. The absolute most crucial point to remember is that calculus isn't magic, and it wasn't just invented to torture high school students. It's the dialect we absolutely must use when things are moving, accelerating, or changing over time. Think about a rocket launching into orbit. It's constantly losing mass while simultaneously accelerating. Standard algebra just can't keep up with that. Calculus was literally invented to speak the language of motion. Now, when we first encounter the symbols of this dynamic dialect, yeah, they can seem pretty intimidating, but let's break them down. That tall, squiggly line, the integral, that's genuinely just a symbol asking you to add up a continuous sequence of infinitely small things.
Just think of it as a stretched out S for sum. Then we have the derivative, d over dx, which pinpoints the exact rate of change at one frozen snapshot in time. You've got the sideways figure 8, capturing the boundless idea of infinity, and the sharp angles of the Greek letter sigma demanding a grand summation. Basically, these symbols are the tools that let us tame the infinite.
And the mathematical universe just keeps expanding outward beyond calculus into several other highly specialized branches. We've got logic, which actually mathematically structures formal human reasoning. There's set theory, which dictates how we group and analyze massive collections of objects, and statistics, which we rely on all the time for data analysis and figuring out probability. Because each of these disciplines tackles totally unique sets of problems, they naturally require their own unique shorthand. But it all builds right back to our core theme of translation. Even something as abstract as the flow of human reasoning in logic or categorizing objects in set theory can be compressed down into these highly efficient visual symbols. See those 3 dots formed into a little triangle? That completely replaces the word therefore. The curve that looks kind of like a rounded E, that simply means an element of a set. And that upside-down U perfectly represents the intersection where different groups overlap. It's actually amazing how much philosophical weight these tiny little symbols can carry.
Finally, Section 5. Why these symbols matter. Decoding reality. So what does this all mean? Well, mathematical symbols act as the ultimate compression algorithm for human thought. They literally turn massive cosmic concepts into solvable sentences. The absolute biggest takeaway for you from this explainer is that these symbols were never, ever invented to confuse you. Their entire purpose is to distill incredibly complex realities, from the staggering gravitational pull of a black hole right down to the tiny algorithms running the smartphone in your pocket, into something we can physically write on a piece of paper and logically work through. They are tools of ultimate clarity. And this brings us to one final, really lingering thought. Are we inventing these mathematical symbols to describe our universe, or are we just translating a language that was already there? After decoding all these different disciplines today and seeing how flawlessly their symbols map to the physical world, I want to leave you with this fascinating question to ponder. Is mathematics a brilliant human invention, or is it simply the fundamental, native language of reality itself, just waiting for us to translate it? Thank you so much for joining me on this explainer. Keep wondering, keep questioning, and keep translating the incredible world around you.